We'll try to go over the problem of finding the resultant of four forces F1, F2, F3 and F4 using the method of components. Note that the angles theta 1, theta 2, theta 3, theta 4, they are measured with respect to x-axis. Further, we know that in this quadrant x component is positive, y component is also positive, whereas in the second quadrant x component is negative, y component is positive. In the third quadrant you have x component negative, y component also negative, whereas in fourth quadrant you have x component positive and y component negative. So we know that the x component of the force F1 is positive, y component of force F1 is positive. Similarly, in third quadrant, x component of the force F3 is negative, y component of the force F3 is negative. And the same thing you can apply to however many number of forces there are in a given problem. Now we try to keep track of the components in a table as shown over here. Okay, we have columns as indicated here. We have one column to keep track of force, okay, which we indicate by I, and another column to keep track of angle, which we indicate as theta I. Then you have a column for x component, and then we have a column for y component. Okay, and then we'll try to enter all this data systematically into the table. Okay, let me try to draw the table as shown over here. Okay, and these are the column lines. We have four forces, so we have 1, 2, 3 and 4 rows here. So we have force F1, F2, F3, F4, and the x component of the force Fi, represented as Fix, is Fi cos theta I. Then y component, represented as Fiy, is Fi sin theta I. So you have terms like F1 cos theta 1, F2 cos theta 2, and so on for F1x, F2x, F1y, F2y, and so on. We know that this force F1 is 100 newtons, okay, and the angle is 45 degrees. Okay, so you have force 100 cos 45 here, okay, and you have here 100 sin 45. Okay, similarly the second force we have F2 is 200 newtons and the angle is 30 degrees. Okay, you have 200 cos 30 and then 200 sin 30. You have to pay particular attention here. The x component of the force F2 should be less than 0 because it is lying in second quadrant. So you put a negative sign here. And then the force F3 is 300 and the angle is 45. So you have force 300 cos 45 is the x component of force F3, 300 sin 45 is the y component of force F3. Note that this F3 is in third quadrant, so both x and y components should be negative. We put a negative sign here, put a negative sign in front of the y component. The force F4 is 400 newtons and the angle is 60 degrees. So the components are 400 cos 60 and then 400 sine 60. Okay, because the force F4 is in fourth quadrant, x coordinate is positive and y coordinate is negative. Correspondingly, you put a negative sign here. Then we sum up the x component and y component. Okay, the x component, if you substitute these and punch the numbers in a calculator and find out, you'll find the sum of x coordinates to be x components to be 114.63 newtons, and the sum of all these y components comes out to be minus 387.83 newtons. So you can see that both are x, this is the x component of the resultant, this is the y component of the resultant, both rx and ry, they are negative. So your resultant must fall in third quadrant here, because the component x component of the resultant rx and y component of the resultant ry, both are negative. Okay, so your force resultant, it should appear somewhat like this. Okay, the pink colored one shows here. Now what remains to be found is this angle. This angle we can call as theta sub r. Okay, to find theta sub r, we will write tan theta sub r is equal to ry by rx without sign, because we have already taken the sign into account by placing the resultant r in third quadrant. So this you can find as 387.83 divided by 114.63, which will give you a value of 3.38, and then taking inverse tangent, you can find this theta r to be 73.83 degrees. Okay, 73.83. So we need to show this theta r as something a bit more than 45. So your force r will be something like this. Okay, and the angle you need to show as from here all the way up to here. This angle is theta r. Okay, any number of forces, F1, F2, F3, F4 in this case, but in a general situation you may have n number of forces, and the method of analysis is exactly the same.
The magnitude of the resultant force R may be computed from the values of Rx and Ry shown in the table here. Rx is 114.63 with a negative sign, and Ry is minus 387.83. Given these values, the magnitude of the resultant R may be given as under root Rx square plus Ry square, which is under root 114.63 whole square plus 387.83 whole square, which comes out to approximately 404.4 newtons. That is, you will say that the resultant R has a magnitude of 404.4 newtons at an angle theta of 73.83 degrees. It may be noted here that all these angles, they are measured with respect to x-axis. You can see that theta is 45, is in first quadrant with an angle of 45 degrees. Here it is 30 degrees with x-axis in the second quadrant. Similarly, the resultant angle is also measured with respect to the x-axis. Okay. The quadrant in which each force lies is decided by the signs of the components as indicated over here.